This meeting is being publicly streamed.
Okay, so last time we discussed about this bridge, this half wave rectification, as I have shown you this diagram. Basically, this diagram is developed a little bit. There is not a big science behind it. It was a half wave rectification, and in all these half wave rectifications, there was one important point which I had to mention with you, right? That if you change the frequency of this input cycle, what will happen? The frequency of the output cycle will also be changed, right? This was the last discussion we made. For example, here the frequency is 60 hertz, then output cycle will be changed. If the frequency is 70 hertz, output cycle will be changed, and according to the time period will be adjusted, right? So today the topic is actually full wave rectification. Okay, full wave rectification. So that topic is basically a topic in which we will be rectifying the alternating current professionally, right? So professional rectification means, there was a problem in this all setup, and that problem was that you have the glitches in your output. The output was off and output was on for several times or several minutes. But now we will be talking about that type of stuff in which it will be actually a smooth setup. Okay, so let me start and text my A2 students as well. Okay, so in this bridge rectification, we will be discussing about that. Sorry, this full wave rectification means that all the wave which will be at the input, I will just consider this as a rectification process. Okay, you know. Okay, last time I have shown you that if I have a box, in that box there can be a rectifier. For example, here we have this rectifier. This rectifier can be anything. Right now it is a rectifier, and that rectifier, let's say I have an input wave equal to this is an input sinusoidal wave, alternating wave, right? Alternating current, and that alternating current is fed to this alternating current will be rectified as the input. Yani till this point it will be rectified, it will be as it is, then it will be rectified. How will it be rectified? It will be rectified in another way. Let's say I will just draw the diagram for you, and then you people will be able to now the concept of rectification. Sorry, here we go. This is the main position, right? This is basically the mean position or equilibrium position. Now if I say that this rectifier, or the function of this rectifier, is to cut this half wave as well as to just make it a full wave, then it would not be wrong, right? This half wave is cut, and now the remaining half wave will be of, or that will be basically, that wave will be just drawn on the half cycle. For example, this will be the wave, this is the wave, so this wave will be now obtained on the upper half cycle. Okay, so I will just erase one half or half of that wave, and I will plug that wave over there. So this is basically the cycle, wave cycle. This is a full wave now. Are you getting my point? Now you have got a complete wave at the output, but in this way. This is called your full wave rectification. What do we call it? What is this? This is your full wave rectification. Now, is this clear that what does it mean by full wave rectification? That half of the cycle is basically clamped and rest half of the cycle is converted into full wave, a complete wave, complete positive wave. Okay, did we
Yes, sir.
discuss this or not? Yes. Assalamu alaikum. Is this clear to
Walaikum salam.
everyone? Yes. Huda, आपने join कर लिया बेटा?
Yes, sir.
Okay. So we are talking about full wave rectification. So this means full wave rectification. You got my point?
Yes.
This is basically full wave rectifier. I think so that we have not discussed about full wave rectifier in detail, although I was talking about that what is rectification. So this was basically rectification and converting AC into DC. Then I used this diode structure, and then I told you about the half wave rectification. Now I will discuss the details of this full wave rectification. So please be attentive and be with me. This topic is that topic which is frequently asked in alternating current. Now this is the positive half cycle, the next positive half cycle, next positive half cycle, and this positive half cycle is obtained at the output. So did you notice that the ripple frequency is now doubled? This one is your negative half cycle. So all negative half cycles have been clamped, or you can say they have been terminated, or they have been clamped, and then they have been shifted as upward, or they have been shifted upward. So that is why I can simply tell you that yes, for example, if I just draw this in this way, basically this must be the input now, this way. This must be the input cycle. You got my point? ऐसे होना चाहिए ना
Yes,
input cycle. So this input cycle will be basically shifted, or that will be now converted. That is actually converted. You've seen this all. That yes, actually input cycle was something like this, and this has been converted into the output cycle. That is why I told you that half of the wave has been clamped and the rest half of the wave is basically converted into, rest half is converted into what? That rest half is converted into positive. So all these negative have been gone, now they are positive. So now the probability of your output is yani to be decreasing, or to be getting switched off is less. For very few time it is now switched off. So this is better the input. Okay, Hanzala and Zoya, it is input, and this is your output, rectified output. Now the question is, what is this full wave rectifier? This full wave rectifier is called your bridge rectifier. What do we call it? This is called a bridge rectifier. Okay, bridge rectifier, and that bridge rectifier consists of four diodes. How many diodes are there? There are four diodes, and that these four diodes make a complete bridge rectifier for you. What do? They make a complete bridge rectifier. Now, is my voice still there? Okay. So this bridge rectification, we will discuss about that. Okay, beta, listen. The important thing that how do we connect these four bridge rectifiers? First of all, we must have a sort of diamond structure, and then that diamond structure will help you out. This is a common. There are several type of diagrams which are used to frame this circuit, but most of the time this diamond structure is used. For this diamond structure, the outputs are connected here, Okay, there are the outputs at this point. From this terminal we provide the output. Okay, first I will complete the circuit, then I will tell you that where I'm going to place the diodes. This is basically one terminal, and this is the input terminal basically. Okay, so this one will be now getting as an output terminal. There will be a load resistor here, and that load resistor will be connected to this. This is one complete cycle, and here I have, or I will connect a load resistor for you. And beta ji, this load resistor is here. This is a load resistor for you. For this load resistor, basically we get, or we provide some output cycle here. तो आउटपुट साइकिल के लिए मैंने इसको क्या कर दिया, दिस इज योर लोड रेजिस्टर. Okay, now is it clear? The circuit, actually circuit diagram is important. If you will get the circuit diagram once, then it will not be a big problem for you. This is a load resistor. Now on this load resistor, along with this load resistor, I can just draw a diagram for my diodes and some other inputs. Yes, these are not inputs basically. The inputs are, let's say, let me draw the inputs with some different color so that it would be clear to you. Now the inputs are somehow in this way. This is the input terminal. Okay. So this input terminal is bypassed. Bypass, do you understand bypass? Do you see? That is not junction. It is basically, this is not a junction. It is just an, this is a bypass. Okay, this is a bypass junction. So bypass matlab, yeah, here, just like this. So it will not be connected with this one. You got my point? That's it. Now, is this jumper clear? Is clear a diagram? Now I will connect the diodes in such a way that depends upon my requirement. For example, the diodes which I will use, there will be some diodes. Let's say these, this is one of the diode. I will connect this diode here, and the diode will depend upon the situation. Our diode will depend upon the requirement of my circuit. Okay, this is one of the diode. So I will connect that diode here. This diode will be connected in this way. This is one of the diode. Because this diode is connected just in this way, just due to one reason, because I need some output as positive terminal, or I need output over positive. So here, this is basically, now this diode will be, this will be now copied. I think so. Yes, this is the other diode in the same orientation. Okay, then you will have some more diodes. They will be connected here in different positions. Okay, this is the other type of diode. That is why I have just connected it. Yeah, this is the green diode, and let's say this green diode will be here. Now, did you see? This is actually a proper setup for the diode which I have provided you here. So this is the first diode. That diode will be working in this way. This is the second diode. That will diode will be working in this direction, and the rest of the diode, these two diodes are plotted, or they are connected in such a way. Why did I do this all? mean, how do I know that these diodes will work in this way? So beta ji, this is the game of this topic. Here, this is what? This is your load resistor, and I need the positive terminal of the load resistor here. In your exam, you people are given that, okay, this is the positive terminal, and according to this positive terminal, what you have to do, you are supposed to, or you are supposed to draw the diodes. For example, here I have four diodes. This is diode D1, this diode is your D2, this diode is your D3, and this diode is your D4. Okay, these all are the diodes. So these diodes are basically connected in such a way that they will work in pair. So this was D2, this was D3, this is your D4. So all these diodes will work in pair. As I told you, they will work in pair. So first of all, why I connected the diodes in this way? This terminal, output terminal, yani the upper half of my um, diagram, your load resistor should be positive, because once you see that there is a positive half cycle available at the input, here there is a positive half cycle. So this, yani actually there is a input terminal like this. Input terminal is connected with the wave, or input terminal is connected with alternating power supply. So beta the alternating power supply means this thing, that this, there is a power supply, and that power supply has two terminals. One terminal is positive, and the one term and the other terminal is negative. So I can say that this is a power supply, and by that power supply, I will just connect these two terminals here. Okay, this is the power supply. So this is end X of the power supply. This is end Y of the power supply. So when I consider the half cycle, the positive half cycle, this positive half cycle will be positive here, that will appear at end X. Okay, when this positive half cycle will appear at end X, what will happen to this positive, or how will it work? Because this positive half cycle will allow this current to flow through in this direction. हाँ, this will, yeah. Okay, this way positive cycle will be moving, or positive cycle will be flowing in this direction from positive terminal. Actually, this is positive cycle. Just hold for a while. Sorry for inconvenience. मेरा बटवा निकालो, उसमें कार्ड में पड़ी हुई है, सिम का कार्ड है, नीचे है, ले जाओ, ये ले जाओ, गिराने नहीं है, नीचे है. Okay, so this will be now flowing through this. When it will reach to this point, basically here is the turning point, or here is the point, or game changing point. Here there are two paths. At this point, or this terminal, or this node, there are two paths. The current can flow through diode number 4, and current 2 can flow through diode number 1. Is it? Do you believe this thing? But diode 4 will work as a, yes, diode 4 will work as a off switch. It is basically, it will not allow the current to flow through. That is why diode 1 will work. And when diode 1 will work, now your current will be flowing through this diode. And when the current will reach to this junction, diode 2 will not allow the current to pass through, because it is again reverse bias. And now your current will reach where? Your current will reach to your resistor. Okay, here, are you getting my point? In this way, you, हाँ जी बेटा, ये बात समझ आ रही है सबको? Okay, now the upper half is positive, lower half is negative, and it means that your diode is basically this pair of diode is working. Now diode number 1 worked only. At this time, current flows through this. It will follow all these terminals here. Okay, this is the path of the current. Okay ji, this is the path of the current. Now the current will reach to the input terminal here. This is the direction of the current basically, and this way. So here, when the current will here. Now what do you think? What will happen at this point? What do you expect? Which diode should work? Diode number 3 or diode number 4? Yes, come on. Which diode will work? Okay, यहाँ से निकालेगा. Okay, diode number 3 will work because this diode number 4 has a little positive at the output. That is why it will not work as a forward bias. तो क्या होगा? Your diode number 3 will work, and that is why your current will flow in this diode in this way. This way. ठीक है? Are you getting my point? Here. जी बेटा. Because current was entering from that side. ठीक है, करंट यहाँ से इंटर हो रहा था ना, देखो डायोड नंबर 4 के हेड से इंटर हो रहा था, तो दैट इज हायर पोटेंशियल एंड द टेल ऑफ द डायोड नंबर 4 इज लोअर पोटेंशियल, so that is why this all happens. तो आपका करंट कहाँ जाएगा? योर करंट विल बी फ्लोइंग डाउन. ठीक है, ये बात हो गई. जस्ट मुझे 1 मिनट होल्ड करिएगा. मैंने आज ही देखी थी वो, कहीं पड़ी हुई है. चेक करो मेरा बेटा, आराम से चेक करो वहां रख के. और ये और जगह भी नहीं, इसमें तो बिल्कुल नहीं है. इसमें चेक करो, उधर वहां रख के आराम से चेक करो. उधर रखो, उधर इसमें भी देखो, आराम से निकालना और कोई भी गिरानी नहीं है. Okay, sorry. Now by this situation, sorry, this was basically a complete cycle. Here the diode, now the current will reach to this terminal, yani here diode, sorry, the current will follow this blue line now, and that way the current will reach to your terminal Y. This is a complete journey. It takes place only in 10 millisecond beta. Okay, which I have drawn in almost 5 minutes. So this is the positive half cycle. Now is it clear? Is this path clear to you all? That how does this current flow in this for this positive half cycle? Is it clear to you? ओके, अब आप लोग नेगेटिव हाफ साइकिल पे देखेंगे. फॉर नेगेटिव हाफ साइकिल, यानी नाउ दिस इज वेरी एक्चुअली इंटरेस्टिंग सिचुएशन दैट बेसिकली माय terminal Y got positive, now positive reached here, now higher potential reached here, and now terminal X got negative. So that is why now the reverse flow is in progress, and your terminal Y will be basically allowing the current to flow through. Okay, this is now the new journey. So this will continue in the same way. For example, I will try to draw less number of arrows for you. Okay, because you people now, okay, करंट का पाथ क्या है. ओके, here current is flowing through this, and this way the current will be basically turning into here. From here the current will be flowing through which path? Opposite to this, opposite to this. So through which diode it will pass through? Diode 1, diode 3, sorry, diode 2, diode 3. Diode 2, yes, very good, the green one, right? So current will flow through this, and right after that, you will see that yes, the diode is now allowing the current to flow through. Now here, the direction of the current will become same, become same. You got my point? That is why I have drawn these arrows in opposite direction. That yeah, that arrows are opposite to each other before the current is or enters, or before the current basically makes an entrance in the circuit, but after that it becomes same. Now the current is in the same direction. So when current is in the same direction here in this resistor, did you see what will happen, or how will you consider that yes, the upper this once this side is now again positive, this side is negative. Before that for blue it was positive and this was negative. Now the current will flow through this path, and the current moves on and on. For example, here the direction of the current will be moving back in this way. Current is in the same direction, current is in the same direction, right? Current is in the same direction, current is in the same direction, and so on. So that means that basically if there would be no diode, the current would be flowing in the opposite direction. So diagrams this diagram helps you out to figure out the direction of the current after being rectified, right? ये देखो, all the arrows are in the same direction after being rectified, red and blue arrows. Now which diode will work? Diode number 3 or diode number 4? Diode number 4 will work. Yes, diode 4 will work because the current will flow through this diode, right? Are you getting my point? And from here, now again current become opposite. Did you notice? It's very interesting circuit that initially current was opposite, in between current was in the same direction, and finally current became opposite to the initial direction of motion, and now this side again it becomes positive. So this circle of positive and negative, it remains for uh, 10 milliseconds in the circuit. Now this is positive. Now, is this diagram clear to everyone? Mhm. Clear, beta? Okay. Now, for input cycle, yani input was basically something like this, and you got this as an input cycle. Beta, this input cycle is now obtained for you here. This is basically the in output. That cycle has been now appeared as output. देखो, this was the input, and now that cycle is actually converted into output cycle. Did you see? This way? Okay, this is an input cycle for the blue color. Okay, yes, for blue arrows this is the cycle. for blue arrows, and the same cycle will be appeared for red arrows. You got this point? Is it? Are you agreed? So this is basically the rectified output of my device at the output cycle. So this is positive, this is positive. So there is no negative half cycle now. Is my point clear to everyone? Yeah. So this is now a rectified output. Now, if I just draw the output here, again, then it will be very clear to you that yes, you have these all cycles, multiple cycles at the output, like here. This is basically the output cycle. Let's say I'm going to place it here for you. This is output cycle, blue, red, blue, red, blue, red. So how many number of cycles are there? Basically there were two cycles, है ना? This was positive of one, the negative of that first, positive, positive. So actually this was something like this was something like this was something like this. Do you agree? Yes. So this is how, if you are asked to have reverse, yani, if you have to draw the diode with the output with negative, yani negative sign at the output, at the upward, yani at the upper edge, and positive at the lower edge, then you have to reverse the diode. What will you do then? Diode will be reversed. Is this diagram and is this all circuit clear to everyone? That is why I told you that it will take. Yes, Hanzala beta, clear hai? Okay, and Huda and Yahya beta, is it clear to you also?
Yes, sir.
Okay, now there is a problem. The problem is still we are not having the smooth output, right? Is it? To have a smooth output, smooth DC, capacitors are used. What? Capacitors are used. So how do you use the capacitors? Right? This is a question. The capacitors are used parallel to the load resistor, right? I can just plug it in here. Parallel to the load resistor. Okay? When you have a load resistor, then at that load resistor, parallel to the load resistor, you can connect the these capacitors. Now these, what will they do? They will make the output smooth. So first of all, I will draw a load resistor for you, and then I will draw the capacitors and so on. Here I have a load resistor. Okay, this was that load resistor simply, and the output of the load resistor is now we connect the capacitor. This is the output of the load resistor, and this is simply a load resistor, you can say. Okay, now I will place some capacitors parallel to that. So beta, when I connect parallel capacitors here, these are the capacitors, these are the capacitors, right? These capacitors can be there. So these capacitors will be connected parallel to the load resistor here. Okay, this is one capacitor. If the circuit will not be smooth, what will I do? I will connect the other one. Okay, and so on. So until unless I do not get the ideal output, the capacitors will be connected uh, accordingly. This is your capacitor C1, this is your capacitor C2. So I have connected all these capacitors parallel to the load resistor. So what happens actually by using the capacitors? The capacitors discharge, right? What happens? The capacitors are discharged. So when the capacitors are discharged, these capacitors are basically these capacitors are used to release the energy, and that release energy is used to hold the voltages of the output cycle. कैसे करते हैं ये? Let me draw that. This is basically the output cycle. I will just draw this all for you here. This is copy. Now this is basically the rippled output. What is that? It is your rippled output. So beta ji, I don't want the ripples. I would make it smooth. So how? This capacitor, when the capacitor will be used, while the energy is being released from this point, let me call some points here: A, B, C, and D. Okay, this is just for one. For one, I will explain the capacitor for one half cycle, and then for next half cycle, it would be very clear to you. When your voltages are increased from A to B, capacitor is charged. Okay, so from A to B, capacitor is charged. Okay, from B to C, B to C, and then C to D, capacitor is discharged. Capacitor is discharged. Now, if you have studied the capacitor action, I told you that there will be a great discussion about capacitor right here in this topic. So please be careful about this all. That here we go. That capacitors, how do they work? Actually, these capacitors are very interesting things. The capacitor have an RC time constant, if you remember. Do you remember that? The RC time constant of the capacitor? RC is equals to T. RC is equals to T. Yani this is basically the time constant. So the time of discharge of the capacitor is used in this way. The discharging voltages, the equation is equals to V is equals to V naught e power minus T divided by RC. So this equation helps you to reach or to manage the time. For example, we adjust the R is sorry, R is fixed, R is fixed, है ना? R is fixed na, the load resistor, and C is adjusted. C is adjusted. So when you adjust your C in such a way to control the discharge time of the capacitor. What? To control the discharge time of capacitor. So beta ji, what you want? Dekho, it is quite simple thing. I want that until my voltage cycle is discharged from B to C and then it increases back to D, my capacitor should be discharged only till this point. So the voltages will be held. The voltages would not be discharged. Yani This is the charging of the capacitor. Okay. Yani capacitor will be charged accordingly till this point. Sorry. And then capacitor will be discharged with sort of voltages. ये देखो, this is basically the capacitor charging, and now your capacitor will discharge to this point. Okay, then again it will be charged. Okay, again it will be charged, and then it will be discharged. Oh, sorry, not in this way. It will be discharged in this way. So capacitor will be discharged here, but these peaks are a sort of curves, right? They will reach to this point. Okay, then again it would be charged along with the voltages, and then it will be discharged to this point. Now again it would be charged, and then it would be discharged to this point. Again it would be charged and discharged to this point, and so on. So beta, this is basically what that you can get the output cycle, the reduced ripples, right? What do you get? You get the reduced ripples. Now if you want to increase the RC time constant of the capacitor, that these voltages can also be smoothened like this. Okay, are you getting my point? Is this clear to everyone? If you want to basically increase the smoothing, or if you want to reduce the ripples, what will you do? You will basically, yes, here is another half cycle. It will be more smoothing. It will have more smoothing. For that purpose, I have used two capacitors. With the help of two capacitors, yani this is basically a single capacitor output, right? What is that? This is a single capacitor output. Okay, beta ji? Single capacitor. And this will be for two capacitors. When you are using two capacitors, what will happen? The ripples would be more smoothen. How? Let's say now I manage the capacitor to smooth my output till this point. Yani till this point means to these voltages. Now I'm going to give you some typical techniques, the calculation techniques. Basically, this question is very horrible question for you. You will have some voltages, right? The voltages are there. Suppose what are the peak voltages and RMS voltages concepts are asked here. 10, 20, 30 volts peak value, right? Okay, 30-volt peak value, and I want to make the voltage smooth to 28 volts. So you will just draw an invisible line at 28 volts, which can be again raised. This is 28-volt potential difference. My voltages will be no more lower than that. Now what will I do? I will draw these lines for my charging and discharging. For example, the voltages capacitor will get charged, and then it will discharge in this way, charge, and then it will discharge in this way, charge and discharge in this way, charge and discharge, charging and discharging, charging and discharging. Did you notice that I have made charging sharper and discharging slower? So in this way, you can set that, okay, your value of the voltages, DC voltages will never go beyond 28 volts. Once the voltages get smoothened, and then they would be basically equal to the same potential. Now I will erase this. This is the entire game what you must know. Is this clear to everyone? The smooth output. Is it clear?
Yes, sir.
Yes. So this is how my alternating current works. Okay ji? Any question you want to ask me? जी बेटा. Sorry, can you repeat your question, please? Yes. If we want to smoothen till 30 volts, basically, then we will have a smooth line. And this is basically what this is a small value. But if I want to make it more, if I put more capacitors, then the value will be smooth at 30 almost. Got it? So with the help of this technology, what do? We make the output smooth and DC. So this is with one capacitor and this is with two capacitors. Is this clear to you? Any confusion, anything you want to ask me from this topic? It was basically a uh, integrated topic because I need some sort of drawing on this. That is why it took time, but I believe that it helps you out. These all schematics, they help you out to get a clear concept. सब clear हो गया? I will send you these notes as well, so you people can see these notes and figure out the concept again. I have shared my worksheet with you, so hopefully you people will solve that worksheet while on this weekend, and this alternating current chapter should be completed. If you have any doubt, anything, we will discuss it on Monday, inshallah. Any question? Okay. You're done. Allah Hafiz. Allah Hafiz, beta. Huda? हुदा
जी सर.
बेटा बातें समझ आ रही हैं?
यस सर.
कंफर्म?
यस.
ओके. आज यही ने क्लास नहीं ज्वाइन की?
नो सर.
नहीं था ना क्लास में?
नहीं.
ओके.